Welcome back to another mission of physics. Today, we will be seeing standing waves.
The problem says, the A string on a cello vibrates in its first normal mode with a frequency of 220 Hz. The vibrating segment is 70 cm long and has a mass of 1.2 grams. A. Find the tension of the string, and B. Determine the frequency of vibration when the string vibrates in 3 segments.
As always, we analyze the problem. Here we have our length of 70 centimeters in the first node with a mass of the string of 1.2 grams and a natural frequency of 220 Hz. We have some formulas when talking about these vibrations, but only one includes, we have to find one that includes force or in this case tension, for which we are going to use this one. So if we see the formula, we see that we are missing the velocity of the wave and the linear density of the string. So for this, we also have the formula frequency equals velocity over 2 times the length. We already have these values of frequency, which is 220, and length, which is 0.70 meters. So we just arrange the equation, and we get a value of 220 per 2 per 0.70, which will give us a value of 308 meters over second. Secondly, we need the linear density, which we know it's mass over the length. We have to remember to convert these values to kilograms and to meters in order to get the correct value, which will give us a value of 1.71 per 10 minus 3. Now, we arranged our previous formula of velocity equals root of force over linear density, which will give us force equals velocity squared per the linear density. We already said that our velocity was 308, which we are going to make it squared per the linear density that was given to us before. This will give us our value of 162.22 approximately, depending on how many decimals do you use. And this will also be our tension. This value will be given in newtons. Secondly, we are asked to find the frequency when our wave is divided in 3. So we have our frequency, which is repeated 3 times, amplifying this frequency, for which we understand that our new frequency will be 3 times the previous frequency, which is 3 per 220, which was the original frequency. This will give us a value of 660 Hz. Those were the results for the previous problem. I hope it helps, and see you in another mission of physics.